Hi everyone, so today we are going to talk about theoretical probability. But before we proceed with calculating theoretical probability, I want you to be familiar with the following key terms. So these are sample space and event. So the sample space is the set of all possible outcomes of an experiment, while an event is a set of outcomes in the sample space that have particular property. So in short, we can say that each subset in the sample space is an event. So event is a subset of the sample space. Okay, so let's have some illustration on how to identify the sample space of a given experiment. Suppose the experiment is tossing a coin 2 times. So in order for us to figure out what the sample space is, the best way to do is to use a tree diagram. So in the tree diagram, we always have the starting point, okay? And then we're going to write the possible outcome when you toss the coin for the first time and also for the second time. Okay. So in the first toss, we could get either a tail or we could get a head. So I will use H for head and T for tail. Okay. In the second toss, we could still get either a head or a tail. Okay. So I will write H here and T here. And then on the second part, I will also write head and tail. Okay. Now we will use line, okay, to create branches. Okay. Now, in order to create the sample space, what you're going to do is you're just going to follow each branches from the start, okay, up to the end. Okay, and as you finish, as you finish, you need to write down every letter you pass, and that's going to be your sample space. Okay. So start and then going to head, then head again. Okay, so that will be HH. Then start, going to head, then head goes to tails. So that will be HT. Okay, follow the same process. So TH, T, T. Okay, so your sample space will be HH, HT, TH, and TT. Okay, and the number of sample space will be the number of elements on the given set. Okay, since we have 4 elements in the sample space, so the number of sample space is 4. Okay, so one way of writing a sample space is using the symbol N of S. Okay, so we can use the symbol N of S to state that it is the number of elements in the sample space. Okay, let's now proceed with theoretical probability. So when the outcomes of an experiment are equally likely, the probability that an event A occurs is given by P of A equals to N of A all over N of U, where N of A is the number of outcomes corresponding to A, N of U is the number of outcomes in the sample space, and P of A is equals to the probability of the event A. So it means that it is the ratio of the number of outcomes corresponding to event A all over number of outcomes in the sample space. Okay? So in general, we can say it like this. So it is the ratio of the number of favorable outcomes, that is the number of events, all over the number of possible outcomes, which is the number of sample space. Okay, let me show you an example. So a ticket is randomly selected from a green basket containing 3 green, 4 yellow, and 5 blue tickets. Determine the probability of getting a green ticket. Okay, so what we need to do is to identify our sample space. What are the possible outcomes on the given experiment? Okay, so our experiment is selecting a ticket in random. Okay, so our sample space will be all the tickets in the basket. Okay, so I will use G to denote green, Y to denote yellow, and B to denote blue. Okay, so my sample space will be G1, G2, G3, since we have three greens. Okay, and then for yellow, I'll have Y1, Y2, Y3, Y4. Then for blue, B1, B2, B3, B4. Okay. And then since the event is selecting a green ticket, so the elements in the event are all the green tickets. Okay. So that will be G1, G2, and G3. Okay, so N of S is the number of sample space. So N of S will be the number of elements in the sample space. So, sorry, this should be a bracket. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There should be 5. Okay, sorry. So there should be another B5 here. Okay. So there will be 12 elements in the sample space and number of event. So the number of elements in the event are 3. Okay. So to get the probability, you'll just get the ratio probability of event A, which is getting a green ticket, will be the ratio of the number of events and the number of sample space. So that will be 3 over 12. So we can simplify this, which is 1 over 4. Okay? So that's how you calculate the probability. Okay, using the formula N of A all over N of U. Okay, so N of A, that is N of E, N of U, that is N of S. Okay, let's continue. So a green or yellow ticket. Okay, so in our sample space, we have 3 green and 4 yellow tickets. So since since we want to find the probability of either getting a green or getting a yellow ticket, so what we need to do is just to add 3 and 4. Okay, so the probability of getting a green or yellow will be 3 plus 4 divided by the number of sample space, which is 12. So 3 plus 4 is 7 all over 12. Okay, so that is the probability. Okay, next, an orange ticket. So if you will look at our given, we only have 3 colors, green, yellow, and blue. So getting an orange ticket will be impossible to happen. Okay, and what is the probability if an event is impossible to happen? Yes, that is 0. So probability of getting an orange ticket is 0 because we don't have an orange ticket in the basket. Okay, next. Okay, selecting a green, yellow, or blue ticket. So green, yellow, or blue, that is already our sample space. Okay, so we are very certain that this will happen because all the 3 colors are possible. Okay, so what is the probability when we are sure that the event will happen? Okay, that is 1. So the probability of getting a green, yellow, or blue is 1. Okay. Okay, so I'll show you another example. Okay. So a probability experiment consists of tossing a coin and spinning the spinner shown below. So the spinner is equally likely to land on each number. Find the probability of each event. Okay, so event A, tossing a tail and spinning an odd number. Event B, tossing a head or spinning a number greater than 3. Okay, so this is our spinner. Okay, so we can see 5 numbers with equal areas. Okay, and then tossing a coin. Okay, so to identify the sample space, we can create a tree diagram. Okay, so let's draw a tree diagram. So this is the start. Okay, so I will start with tossing a coin. What are the possible outcomes when you toss a coin? So tossing a coin. So the possible outcomes are head or tails. Okay. How about the possible outcomes when you spin the spinner? Okay, so these are the numbers 1, 2, 3, 4, and 5. Okay. So 1, 2, 3, 4, 5, and then on the second branch also 1, 2, 3, 4, and 5. Okay. I will write the outcomes by following the branches. Okay. So I'll just connect using lines to indicate the branches. Okay, so this is the starting point, then H1. Okay, so our first outcome is H1 using the same process, so it follows by H2, H3, H4, and H5. Okay, then let's have the tail. So if the coin lands on tail, so the possible outcomes will be T1, T2, T3, T4, and T5. So these are our outcomes. Okay. So since we already identified our possible outcomes, then we can now solve the two questions. Okay. So we list down all the sample space. So H1, H2, H3, H4, H5, T1, T2, T3, T4, and T5. Okay. So the first question is finding the probability of event A, which is tossing a tail and spinning an odd number. So since we're talking about getting a tail and an odd number, and the odd numbers are 1, 3, and 5. So the number of events will be 3 and the number of sample space will be 10. Okay, so the probability of A is 3 over 10. Okay, so the probability of tossing a tail and spinning an odd number is 3 out of 10. Okay, next, event B. Tossing a head or spinning a number greater than 3. So the numbers greater than 3 are 4 and 5. Okay, so it should be H4 and H5. So we have, so the number of event is 2 and the number of sample space is 10. So the probability of B is 2 over 10 in simplest form, that is 1 over 5. So that's it. So that's how you use the concept of theoretical probability when you are computing the probability of an event. Okay? So it is different to experimental probability because in experimental probability, it is based on the observation, while theoretical probability is based on expected outcomes. Okay? So I hope you understand how to compute theoretical probability. I will see you in my next class. Goodbye.